Now today the practical will be number fourth, and it would be basically uh, the practical will be number fourth, 2:1 MUX using transmission gate. Here in YouTube or Google you can find several diagrams. We'll be implementing this specific one, but the main important thing is the inverter stuff we are not going to include. Either two different sources can be taken as a bit stream, or I can give the select line as per my choice. Only the thing is we don't have to use this inverter, because the inverter we can extensively analyze it by consider it into a different practical. So it will be number fourth. So let's get started with this. Again, going to edit. Okay, creating a new design. This is practical number 4. Okay, then adding the libraries, devices, then adding the miscellaneous components, adding the spice commands. Okay, adding the spice elements. Okay, creating the self new view. Okay, now 2:1 MUX using the transmission gate. First we need to implement the transmission gate, and then we are going to get that. First of all, we'll create a transmission gate by putting PMOSes and MOSes. PMOSes, we'll rotate it, right? This is P. I will be needing 2 PMOSes and 2 NMOSes. Then NMOS, just need to rotate it. Done. These can be connected by wires. Here just connections can be done using wires. Now the voltage sources I need to take can be of type bits. So spice elements, voltage source, these are of type bit. I can change the pattern here by this is, I consider my input A. I can also change the pulse width so that a clear waveform, clear cut waveform will be at the output 40. It's okay. This second, this is my input B. Oops, yes. Now I need to select, give the select line. I can take it as B, a different source, and again I will be needing a different source here because I'm not going to use an inverter. Okay, So let's take that source here, the third source, and the fourth, as no inverter is going to be used. uh, let's give it here only. Okay, done. Now these two needs to be exactly opposite of each other, right? If I say it is a select line, select, then this should be my select bar, select bar. Okay, so that it will not give any confusions. Here we can put sources as A and B, voltage sources to be A, here this to be B. We have changed the pattern of this to, we need to give the pattern exactly inverse of these select and select bar. Now the remaining part is only the part of connections, giving proper grounds. Into miscellaneous we are going to give grounds like this. Okay, done. This is my input, this is my input, this I need to join. Then again the inputs needs to be connected like this, and these are the inputs going to be connected like this. Select bar and select line, this select line, this is select bar. This needs to get connected, right? So the outputs from here needs to be taken out, right? So output, let's say y is the output. Okay, these I can label as my inputs. Editing this, I can give the input as A. Okay, give my input as B. This is B. My select line is also an input. You can keep this select line at the output. Give him select. Okay, let's see. The first of all we need to change the pattern of these two, because patterns have not been changed here. So pattern needs to be changed, this pattern. Zero zero 1 1 0 0, exactly inverse of this should be 1 1 0 0 1 1. This is the whole design of transmission gate. Now need to do setup simulations, just general, include this library file. If it's not working, it should work actually, but if it's not, then go to include desktop, manually can define the NMOS parameters, then going to transient analysis, just give here stipulated times 10 nanoseconds. No additional things needs to be done. Now what the things we need at the output, these are print voltages. I need the voltage of this, I need the voltage of this, I need the select bar or select line. Anyone will be sufficient enough to know what's the status going on here. Now If it tries to create a confusion or overlaps, I can just rotate it, put it as per the aesthetics, saving my design, and then checking for the output. Let's hope it should come to be proper. Actually, it should come. Let's see if we have missed anything or what. Output is there. What it is, we need to see. Okay, right. These some spikes are going to come. Why? Because I have not connected those substrate terminals. If we connect it properly, the output will be smooth. So here we can verify. These are A, B input select line, and this is my output Y. So when my select line is 0, my A is going to get transmitted at the output. But as soon as the select line goes to 1, whatever my B is there is going to get copied as it is. This verifies the timing diagrams of 2:1MUX. So here there is provision to find the minimums, maximums, the markers. We will be needing this into the transfer characteristics of inverter, so that if you want to perform any analysis, we can take the points from these. So that's it. This is it for C4 warnings. Due to the substrates are not going to get attached to this, and in the S-edit, proper inputs and proper terminals are going to get into the substrate terminals. Also needs to be connected here for a clear output. So thanks for watching, and let's see you in the next video. If you have any kind of doubts, please put into your comment sections, give inputs, give your comments by clicking into like, dislike, subscribe as per it feels how important or how useful these are going to be. So hope to see you in the next tutorial or next video, which will be our practical number 5. It will be on inverter, the inverter transfer characteristics and the timing we are going to verify, and we'll just elaborate some kind of analysis which can be done using the transfer characteristics of inverter. So see you.